Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good afternoon. Thank you for staying. My name is Arkady Retik. I'm the chair for this session on education. And this is a good time to verify there is a parallel session on life sciences. Okay? If you're interested in that one, is in room 104, just downstairs here. So this is probably your right choice. This is the best session to stay. And welcome. We have 3 presentations here. And also to mention that this session is broadcast live, so some people around the world watching us. So this is why we will try to stick to the schedule. Every presentation will be allocated 30 minutes, which include questioning. So we suggest keeps like 20-25 minutes to present and then questioning. So there are 3 exciting presentations, and the first one will be on InstantLab 2, a platform for operating system experiments on public cloud infrastructure. This will be presented by a group from Germany and led by Professor Andreas Polze, who is the operating system middleware professor at Hasse-Plattner Institute of University of Potsdam. He is have a long record of doing very interesting work from both research on distributed system, middleware, and cloud, but also he doing very exciting work on teaching and learning this environment, and this is what he will be talking about. He is also and we need to applaud Andreas for bringing 5 or 4 students here. He's a PhD and master student who are also not only helping on his work, but also learning here. And one of them, Christian Neuhaus, will also helping to present. And without, I'm just pass the microphone to Andreas. Thank you.
Thanks, Arkady. Okay, good afternoon, everybody. Title of the presentation is InstantLab 2.0. And as Arkady mentioned, Christian Neuhaus, who is a PhD student in my group, will give part of the presentation, and Rehab Al-Nema is another PhD student. She is almost done and contributed to the paper. Lisanne Kessler and Frank Schlegel are 2 master students who work in the implementation of the InstantLab. What is InstantLab about? It's not about cloud curricula. If you read this announcement from Microsoft, you might think that everybody is now using the cloud for teaching, but it's not. What they're telling here is that your curriculum should incorporate some cloud-related material. We think in the opposite direction. It is about doing traditional or covering traditional software engineering topics, covering operating systems topics, but using the cloud as an infrastructure where you run your experiments. What kind of experiments? For many years, almost 10 years now, we have been giving undergraduate and graduate lectures on operating systems using Windows as a case study. Materials have been available since 2006, I believe, as curriculum resource kit. And there is also a version of the Windows kernel which is called WRK, the Windows Research Kernel, which we use in our experiments. So InstantLab started out as an idea, or started out from our expertise in using Windows as a vehicle for teaching operating system concepts to undergraduate and graduate students. Windows by itself is interesting. The Windows Research Kernel gives you access to all the internals, all the details. If you pick up the right DVD, there are 3 DVDs and you can choose. And your chance is 1/3 to pick the right one where this Windows Research Kernel will be on. So it's in the faculty resources. this is good, this is interesting. What do you do with Windows Research Kernel? We defined a three-phase approach. And phase 1 and phase 2, the U phase and the M phase, are pretty much applicable to any software engineering project. First thing is you learn interfaces. We call this the U phase, like user mode. You concentrate on OS concepts, you talk about APIs and systems programming. Then comes the M phase, where you talk about monitoring. In other software engineering projects, that would be like testing. So you want to observe the concepts at runtime, you want to introduce the monitoring tools, and you want to do system measurements. And then comes the K phase, and this is unique to operating systems, that you talk about the kernel, which means students are asked to implement new system calls, for instance, are asked to change system data structures like the list of processes and so forth. And obviously this works well for Windows, but also for other operating systems like Unix or Linux if you want to. Now, after giving this lecture over and over a couple of years, two challenges came up. One challenge is your equipment will eventually retire, right? You get a new notebook computer, you have to set up all the software, you figure that the configuration you used on the other computer is no longer available for download, so you have consistency problems if you run the test and demonstration and experiment environment. It is a question of work, just effort, setup work, but it's also a question of aging and changing software. So the idea was, instead of doing this on the presenter's notebook, instructor's notebook, or on a student's notebook every time new, the idea was to put the test and experiment environment in the cloud. Actually, there are two separate problems. One problem is you want to keep experiments in a reproducible form. This has been solved by using virtualization. And in fact, Alexander Schmidt, a former PhD of mine, who is now with Microsoft, he produced an entire set, 7 or so, of experiments which are available via MSD and AA and target WRK and Windows 7. They come as virtual machine images. So you take them, run them on your computer, and do the experiment. The other problem that you, as presenter, as lecturer, have to set up your environment locally in order to run these virtual machine images, this problem remains. And here the solution would be, if we had everything in the cloud, then we would just go to a browser-based interface and run experiments from there. This brought us to the architecture printout or blueprint for InstantLab 2.0. You want to have front end. This front end gives you some interface to the experimentation. You want to have management for the virtual machines. And turns out that these kernel type experiments are particularly interesting because in order to do kernel development or kernel debugging on operating systems, you typically need two systems. You have one system under test, and you have a second system where you run the debugger on. Now, with cloud, none of the cloud providers today offer you to connect two computers via serial link, serial line, and then expose them to the internet. So VM management is an interesting question, also storage. And then we just were not sure about the right interface. Turned out Amazon was early and the de facto standard. So we defined our architecture to use Amazon Web Services as interface. But we also have provider for other clouds. One of them is a private cloud, Hyper-V based, which runs in our data center. And then the question comes up, how do we address students? As long as you do everything in your own private world, in your university, in your lecture, you know the students, obviously. But what if you want to go broader scale? To give you an idea of what to expect from the environment, this is a screenshot running little performance monitoring experiment in the cloud. And here your web browser-based interface shows some paging activity. This is another screenshot showing debugger and debuggee, so two systems interconnected via a virtual serial line. And this is a so-called kernel type of experiment. And this is actually a little movie showing our management infrastructure, which allows you and allows an authenticated and user to start up virtual machines and to get an interface to the machines and to link these systems into the system under test and debugger. It goes slowly. This is something you have to notice as well. All this cloud vision is nothing like on demand and next second you have the system running, but it takes time. Bringing up virtual machines takes up to 10 minutes, also in Azure and in the other public clouds, but also in the private cloud. So the story is basically if you wait long enough, you will get the screenshot you saw before. Okay, let's go over this. And now we change roles, and Christian is talking a little bit about his research. And I'm supposed to.
Andreas, this is the part that I'm going to talk about because it's the bit in this project that actually concerns me. So up until now, we've been talking about InstantLab as a sort of closed-off version that we've been using in our own university, where we used it for teaching students an undergrad operating systems class, and maybe just a few connected schools. But the part that I want to talk to you about is what's the actual 2.0 part that in making InstantLab public. So there's a current trend of making teaching material available online increasingly. There's, of course, the Microsoft Faculty Connection, which the Windows resource kit is part of. We contributed to this with the curriculum resource kit, with the exercises. There's actually Stanford making, has been making lectures available for quite some time now. There's a huge supply of online lecture material on iTunes U, which our Hasso-Plattner Institute actually contributes to as well. And I think about 1% of the German speaking downloads are actually HPI lectures that have been recorded at our place. And similar to the Microsoft Faculty Connection, there's the Academic Alliance of IBM. And we want to follow that trend with InstantLab by not only making teaching material available online, but actually putting exercises on the internet for to be used by the public. And we want to do that by using public cloud infrastructure. We actually have been doing this in the current version of InstantLab, but we want to do this on a fully self-service platform, and that's the actual tough part that I want to talk about. So, like I said, InstantLab, as we've been using it up until now, has been limited to a group of users, which means it's a number of users that you can actually oversee, and you know them because they're the students at your university. But if you actually make it available to the public as in actual 2.0, it's first of all a potentially very large group of users, and the second fact is you know nothing about these users. They come to your system fresh and you don't know who you're dealing with. And the problem with that is, first of all, how do you deal with the administration effort to administer and manage all these people? And secondly, how do you decide who gets to use which resources of your platform? And this is the reason why we want to make InstantLab fully self-managed in the future. And there's two important points here that I'm going to explain to you. The first very important thing is we want to make the self-management completely working on trust relationships we develop with the users. And secondly, we want to have the provisioning of experiments to take place fully automatic in the future. But so about the motivation for having access control based on trust. Why do we want to do this? We provide experiment resources to the public, and these experiment resources actually cost money, and resources on a platform, even if they may be plenty, they're still costly and they're limited at some point. And we know what cloud platforms can't do up until now is actually to cap resources at a certain level. So if you want to say maybe hand an amount of resources to a student worth $10. This is not currently possible. You can just grant access and hope they're not going to exceed your limit. But what you might want to do is to... Hello? Does this work? Okay, works very well. Is that okay? Okay, so as I was saying, we assume you might want to do something with this, like this with your resources. But the question is now, how do you find out who of your users who initially you know nothing about is an expert, who is a beginner, and who gets to be an advanced user? Well, our idea is that you use the interactions of the users with the platform to constitute a user's reputation. Should I switch to this? Okay. So we use things that the user does on the platform to constitute a reputation of the user. So that could, for example, be successfully completed experiments and the evaluation of the results of these experiments. We could look at community interactions. So if users provide good advice to other users on the platform, that could constitute a good reputation of a user. Just as well, we intend to have online lessons and quizzes, so we can actually test for the learning process of these lessons, and not least referrals and recommendations made by others for certain users. So this is a user's reputation, but there's a different term that we need to use for that, and that is trust. And trust is what you actually make of these reputations. So actually, all these things that constitute a user's reputation, you have to bring on your own weighting scheme and your own calculation scheme, and by that you derive a certain level of trust you place in that user. And just to explain a little bit more about that concept of trust, it's the degree to which you're ready to actually confide in someone who's using your platform. And it's specifically not a yes or no value, but it's actually on a sliding scale. For example, a trust value you have in a user could be 0.73. And the second important thing to note is that it's a multidimensional value. So you don't only apply that trust value in one general category, but you can rate users and services if you think they provide a correct computation, or they are reliable, or they do not intend misuse of your platform. And it's also something that can be applied between humans, between actual services on the internet, and between services and people. And this middle category is actually what we want to do, because we're providing a service, and that service makes decisions based on how much trust we place in the user. The question is now, how do we actually develop a trust relationship with a user? Like I told you, when someone first comes to this platform, we know nothing about the people. They just sign up with the platform. What we want to do in the first step is we want to assign an initial trust value to that user, because we need some value to get started with. And everything we can find out about the user in advance, we use to constitute that initial trust value. So, for example, we might know from a user's email address that he's affiliated with a research institution, or that he's a computer science student. And this would actually be a reason to assign him a higher trust value. And what we do then, consequently, whenever the user has an interaction with the platform, like completing an experiment, providing advice to other users, we use that according to our own calculation scheme to influence and potentially increase the trust value we have for that user. And now I'll tell you, we want to use that trust value to actually control who gets to access which kind of resources. Well, we're imagining to work something like this. To each one of our resources, we label them, how expensive and how high level these resources actually are. So there might be these user mode and metering experiments that we don't rate so highly in cost value. So we don't require as much a trust value for these experiments. But for example, for the kernel experiments that involve cost-intensive 2 virtual machine debugging sessions with the platform, we require a very high trust level for the user. And for example, in a case like this, when a user comes in with a trust value of 0.85, he could actually do the first 2 categories of experiments, but the most expensive category of experiments is not yet available to that user, only if he completes further experiments on the platform and increases his trust value. So this is it from my side, and I will give the floor back to Andreas.
To summarize, this is the idea. So you have something which is called reputation, you have trust, and you have basically history on the platform. This history is established through experimentation. This is one piece of history, and through tests, if students undergo tests. And then we have the idea of community. Basically, you can also think of ranking schemes that eBay uses and other 2.0 kind of applications typically use. Turns out, in order to run all kinds of experiments, it is very desirable and necessary, in fact, to connect a public and private cloud here. So we are planning and are in the process of building our own private cloud in the lab. And we evaluated the different platforms available for building cloud infrastructures today, and came up with Open Nebula as a platform of choice. This is due to the fact that not all private cloud platforms support all kinds of virtualization techniques for running VM images in the cloud. And I mentioned before, our previous infrastructure was Hyper-V based, and this Hyper-V or Microsoft virtualization is supported by Open Nebula, but not in other private cloud infrastructures. The next big thing is authentication. How do you authenticate somebody whom you don't know? The idea is when a user comes to the platform for the first time, he will get assigned an ID, a random ID basically, and using this ID we can recognize the user later on. We want to have a session concept, we want to have a single sign-on, we want to have secure connection between the user's display and the cloud computer where the experiment runs. And turns out there is a number of options how you do the authentication. So we are currently planning to go with OpenID in this place. And connecting with the cloud from the browser, that sounds very easy. But if you ever try to acquire the boot screen from your computer for a screenshot or whatever, then you know where the problem is. If you do kernel experiments, then most of the action happens before the operating system actually starts. So you want to display the boot screen from your system under test via some remote desktop protocol or via VNC. You want to do this in a secure fashion, and you want to do it in a portable fashion so that it can be displayed in any browser on the market, which means IE4, maybe not. Our current solution is based on JavaScript and HTML5. However, we are also planning to support applet-based approaches that would run in very old browsers. Because if your target audience is the entire internet potentially, then you cannot be sure about the environment that's being run by the consumers. At Hasso-Plattner Institute in Potsdam, we started 2010 with a project which is called Future SOC Lab. Idea was to acquire up-to-date and pre-production hardware from a number of vendors for experimentation with large databases and consolidation, virtualization, high-performance computing. So large vendors, large computers. We got a couple of, actually 3 of the DL980s, which have 64 cores, 128 logical processors, and 2 terabytes of memory. We got also from Fujitsu a couple of computers. IBM is giving a system which is not Intel architecture. So a number of partners, among them SAP. And if you would be interested to connect with the lab, there is a call for projects twice a year. There's a steering committee, and you just can go and propose a project title and a project proposal, and will eventually get access to the computer resources. And latest addition was the 1,000-core computer, which is basically a cluster in a box, if you will. But this thing has really 1,000 compute cores. Each of these nodes comes with a terabyte of memory, so it's 25 terabyte memory. It's about, I believe, 100 terabyte of SSD, and then some storage behind. So this is not big in the terms of the exascale and whatever have you there projects, but to be available at a university institute, it's not bad either. So this is the place where we are going to run our private cloud, and that brings me to the conclusions. So first, we learned that maintaining operating systems experiments so that you can demonstrate it to your students, that you can give assignments to students, and just use it for teaching, this is a cumbersome task if you want to do it for a number of years in a row. I mean, doing it once is interesting. Doing it a second time and a third time becomes a challenge. On the provider side, virtualization is the answer, because you can roll up everything and put this into a virtual machine image and show the virtual machine image on the student. However, the student still has to maintain his or her environment. And putting the experiments into the cloud would lift that burden on the consumer side. Next, we learned that not all the clouds are equal, right? And in particular, public clouds, none of them, I mean, Azure, there are some not really announced features, but none of the public clouds today allow to talk about co-locations. So if you want to say, please put these two virtual machine images on the same physical hardware, there's just no vocabulary for doing this. And it can get even worse if you want to ask for co-located physical computers. The best you can say is, get me on the East Coast or on the West Coast. That's the level of granularity. The conclusion from that observation is that we need to deal with public and private clouds simultaneously. We need a generic architecture for public and private clouds. In our first experiments, because Amazon was readily available, we choose Amazon Web Services as the quasi-standard, but we have interfaces to the other clouds as well. And the final bottom line, basically, if you want to go internet scale, if you want to provide experimentation and teaching offerings to many students, then everything has to be self-managed. You don't know your audience, so the notion of trust and reputation is crucial in the picture. And our approach is to adopt techniques that have been established for social networks. This concludes my talk. Thank you for your attention.
A couple of questions.
I'm sorry, I didn't understand what you do with the Windows kernel debugger.
Okay. Yeah. This is the thing. There are a number of experiments you can do on an operating system. You can write a program that exercises certain APIs. Or you can use performance monitor like here and see the value of performance counters changing and so forth. But you also can go ahead and say, I want to change the kernel. I want to implement a new system call. And this is what we do with our students.
Right, I'm sorry, you can't attach a debugger to a virtual machine across the internet. So that's what I meant by what do you do with the Windows kernel debugger?
No. The Windows kernel debugger is a piece of software which comes from Microsoft, obviously. And this makes assumptions about the underlying hardware. And one of the assumptions is that this Windows kernel debugger will talk to the debuggee via a serial line. And now the question is, if your debuggee or if your debugger is running in the cloud, how do you connect those two? And certain virtual machine environments allow or have the notion of virtual serial links, and others don't. And the challenge is use one of the public cloud infrastructures of your choice, set up 2 VM images, and get them running and have them linked together. And this is not possible.
More questions? Thank you, Andreas. Thank you,
Okay.
group of students. Our next presenter is from Singapore. He's a faculty of Nanyang Polytechnic University, and it's Gary Lim. He will be talking about how they implemented cloud computing teaching in the university. Also, interesting aspect, I think Gary was working with Microsoft Innovation Center, and they set up some technology center that they helps introduce teaching to other universities in the region.
Okay, very good afternoon to everyone. Thanks for having me over here. Extremely excited to attend this event, despite the 16-hour flight from Singapore. So forgive me if I'm a bit slow this afternoon. All right, I'm Gary. I'm actually from Singapore and one of the leading tertiary institutes, Nanyang Polytechnic. And I'll be sharing with you this afternoon on how we collaborated with Microsoft in order to infuse cloud computing into all our IT diplomas in Nanyang Polytechnic. Let me start off with just running through some agenda that I have planned for this presentation. I'll probably talk a bit about Nanyang Polytechnic, or in short, NYP. I will speak a bit about the curriculum that we have, the structure, and this will really form the background of how we actually infuse cloud computing into our actual curriculum. Then, of course, I'll go into the gist of the whole presentation about cloud infusion and how our students can benefit from that. Not forgetting a practical approach by project development. I'd like to highlight some student success in various areas. And going forward, how do we see this collaboration going, and how will we be taking cloud computing in Nanyang Polytechnic to a higher level? And we'll end off with a short Q&A. So let me first start off with what Nanyang Polytechnic is all about. We are basically located in Singapore, small island in the eastern part of the world. Established in 1992, so we just celebrated our 20th anniversary. So we are relatively young, about 20 years old. And our vision is really to be a premier polytechnic of global distinction. And I will share with you how we've actually brought ourselves to the global stage, got our students known by other universities around the world. At the moment, we have about 15,000 students and about 1,003 faculty members working across a single campus in Singapore. We were awarded the Innovation Excellence Award in 2009, and this is really something that I'd like to share because Nanyang Polytechnic prides itself with being innovative, using IT in different ways for students to think and do things differently. And more recently, in 2011, we were awarded the Singapore Quality Award, and this is really a recognition for our world-class standard in terms of performance excellence. And this award is actually awarded every year to only 1 or 2 companies in Singapore. So I have a short video clip on how the whole journey started. So this is about a 2-minute video clip.
Is cloud computing? Well, cloud computing essentially lets you store data on someone else's computer server. Companies like it because it helps them run more efficiently and they don't have to maintain as many internal servers.
You can access software or your information online without having it to be stored locally.
Total cloud spending will top $40 billion by 2012. That's almost triple last year.
This is the time, it's the opportunity, and the cloud forms the basis.
Windows Azure is Microsoft's cloud computing platform. It's that it's designed to be a place to run your application at scale out on the internet.
Now, with the launch of the NYP Microsoft Cloud Innovation Center in April last year, it's really, to us, it's a landmark collaboration because we are bringing together the best of education and the best of software technology. The objectives is really to train students through curriculum by infusing cloud computing in every single aspect that we teach daily in Nanyang Polytechnic. This collaboration also allows us to access the latest in the cloud services provided by Microsoft, and this includes things like Office 365 and many, many others. The center also engages in R&D, research and development work to provide solutions to the industry, and this is noteworthy because the students will be working in close supervision with the lecturers involved to deliver actually real-life industry projects to clients. We will also train students in professional certifications in Azure to attain their Microsoft Certified Professional Developer certifications, as well as, of course, internship opportunities for our students in both local and overseas Microsoft subsidiaries. This article on the Business Times in Singapore really articulates the things that we are doing. And at the end of the day, we are going to train 4,000 students to be cloud ready by the time they graduate after their 3-year stay in Nanyang Polytechnic. This picture was taken during the launch of the center, and we are really, really happy that it was actually graced by Mr. Kevin Turner, who flew down to grace the launch of the Cloud Innovation Center. 19 April 2011 was by far the most stressful day in my working career to launch actually this center, but I'm happy to mention that the efforts, the hard work, and all that has done the students a tremendous, allowed them to reap the benefits of all these hard work and efforts that we have put in. Let me just touch on a bit about the curriculum structure that we have for students over the 3 years. We actually have, at the moment, 7 IT diplomas from the School of Information Technology. The flagship one being the Diploma in Information Technology, which was started in 1993. That was the first IT diploma that we actually launched. To date, we have a total of 7 diplomas. And if you notice by the names, we actually fuse in both business and engineering together with IT, because IT is the predominant force in every aspect of our lives today. We have a staff strength of about 142 today and an annual intake of about 730 students annually. The course structure basically divided up into 3 different years. In the year 1 and year 2, we train our students in the core and fundamental aspects of what IT is all about. Subsequently, they will actually specialize in areas which they are interested in. It could be information security, it could be games design, it could be many, many other specializations that we have. We also end off with a semester project at the end of each semester. Basically, one semester, it's about 6 months, and we end off with a big semester project where students work in teams of 4 to 5 members, and they develop and deliver an actual solution that is cloud ready. On year 3, students, similar to all other institutions, we send our students out for company attachments as well as doing a final year project. We also have created an option of general studies, and this is really to train students outside of the IT curriculum, things like effective presentation skills, leadership training, and this is really for them to hone their soft skills and also life skills. And in our Diploma Plus program, we actually call the students back during the summer vacations to actually equip them with the necessary technical knowledge in order to pursue professional IT certifications, such as your Microsoft Certified Professional Developer. And all this added up together, we of course hope that the students will be able to learn some soft skills and also hone their life skills as well. Now, the gist of the presentation is how we actually infuse cloud into each and every aspect of our education. This chart, pretty complicated, but let me just summarize what happens. Now, in our collaboration with Microsoft, we've signed an agreement for 3 years, starting in 2011, right? Though the agreement is going to be for 3 years, we are pretty sure that this marriage will probably continue much, much longer. Now, in our year one of collaboration, we took it progressively, and we infused cloud computing into 30% in the first semester, the first 6 months, and subsequently increased it to 50%. We believe that this progressive approach will allow students to undertake and understand cloud computing progressively rather than going with a big bang approach. In our year 2, we are expecting 100% cloud infusion in all 7 IT diplomas that we have. And of course, in our year 3, we would expect that 4,000 students will actually be trained in cloud computing to help in the manpower needs for Singapore as well. I've classified it under several different categories. In terms of certification, in this area, we're actually sending also staff for certification to actually take the certification so that they will be able to train the students. And we'll launch Diploma Plus modules to actually help them in terms of preparing themselves to take the 3 exams that will qualify them to be a MCPD in Windows Azure. So we're targeting the first batch of students to actually have their first certification sometime in the later part of this year. In the area of industry projects, which I will share some later as well, we've started on things like Surface 2 development, Kinet development, and along the way, we'll of course start with Windows 8 project development. As you can see, my slides are also Metro inspired slides. Okay, so working together with Microsoft, we have actually developed this Cloud for Classroom kit. And in this kit, what it does is that we have a series of lecture materials as well as hands-on labs. So we are using this, and you can see it's pretty comprehensive. We have all the way, the entire spectrum of introduction to things like more complex stuff like cloud security in terms of identity and access control, Azure reporting for analysis, business intelligence, and analytics. So we actually have this entire package of materials which we are using, and we cherry-pick some of the materials to be fitted into some of the modules, be it in the year 1, year 2, or year 3. Our Cloud Infusion framework, this portion may seem familiar to you. You may have seen it in some of the slides. Now, basically, I've classified it into 3 different parts. One is like the cloud computing modules. Now, although we have the Diploma Plus modules and all that, which I mentioned, the cloud computing modules are actual cloud modules which are run every week for 30 to 60 hours throughout the semester. And these will basically teach students the entire spectrum of cloud computing. Once they finish these modules, they'll move on to their final year projects, where they will also use their cloud computing knowledge to deliver solutions to the industry. And subsequently, for students who aspire to get their professional certifications from Microsoft, they can actually opt for the Diploma Plus program as well, which is conducted during the vacations. The whole suite of Microsoft software that we actually use in order to help our students gear up and understand what cloud computing is all about, from productivity all the way to platform over here. In the area of project development, we have actually set up a Center for IT Innovation. This center works closely with the industry to bring in projects, real-life projects, for students to actually work on together with their supervisors. These are the industry partners that we have worked with so far. And since our inception, we have about 180 projects with 85 different companies so far. We've also gone into patent filing, where we've filed 29 patents and achieved 21 that were granted so far. Later on, I will share with you one of the patents that we filed using cloud computing as a platform. So yeah, this is the one I would like to share with you. It was done by my colleague back in Singapore, and it's virtualized cloud storage. Now, we know that cloud computing provides all of us the convenience the usability, and anytime, anywhere access to information. But security is one main concern. So when you have a confidential document, a physical confidential document, and you don't want anyone else to know the information after you've read it, you shred it, right? So in this project, what we did was, it's an R&D project. We took a logical file, a computer file, and rather than upload it, a single entire file up to the cloud, what we did was we shredded the file into several pieces, all right? And we used information dispersal algorithm to actually split the file. And at the receiving end, if you want to pull back the file, you have to use the same algorithm in order to put it back. Right, it's pretty complex, and I'm not the principal investigator for this project, but in general, the idea of this project is really to allow a more secure transmission over the cloud. We also have other cloud innovations, such as as I mentioned, students will actually go out to companies to actually work in their final year for internships. So in order to track their progress and all that, we have actually developed an industry learning progress log, whereby students can actually log down their progress in terms of what they're doing, the tasks that they've completed. And this can actually be accessed by both the supervisors as well as the persons in the company, right? We've also developed a collaborative framework for a major telco in Singapore. This is to help their knowledge management and collaborative learning environment using SharePoint Online. And also in the area of GIS, we've developed the first GIS application on the Windows Phone using Esri as the API. And more bit of R&D, we've used cloud computing, Windows Live, to actually control home applications via remote commands through the Windows Live application. We've also worked with Microsoft and also together with our students to actually develop a whole suite of Windows Phone 7 apps that you can find in the marketplace. And this was actually developed even before the official launch of Windows Phone 7. I'll just end off a little bit by sharing some of our student success. I think more recently, in April this year, I'm sure you've heard of the Microsoft Imagine Cup. It's touted to be the premier IT competition for students. And students from the School of Information Technology at Nanyang Polytechnic actually clinched the national champions. And their solution was everything about cloud and Windows 8. They'll be heading to Sydney, Australia in July to actually compete in the worldwide finals. In Singapore, we also have the first ever Microsoft Office 2010 ambassador. And this was a national search for the best student who makes use of Microsoft Office to both manage his personal and professional life. Going forward, we believe that the collaboration with Microsoft and Nanyang Polytechnic will definitely allow us to continue delivering top quality cloud-based education at no extra cost. Now, the no extra cost is actually really a beneficial thing to us because we are a non-profit organization, and for all our students to try out cloud computing using Azure, I think this is definitely a big step forward. We will also cultivate students through expert Azure advice, and you've seen through the video that we have educational seminars held in Nanyang Polytechnic together with Microsoft, and we do knowledge sharing, information exchange, and all that during these sessions. And of course, Singapore is also adopting cloud computing in a very big scale, on a very big scale. And by training all these students to be cloud ready by the end of 3 years, it will really enable us to meet the manpower needs of Singapore's IT industry. So with that, thank you.
Any questions? Jeffrey? You mentioned things like 100% involvement of cloud computing or something.
Right.
I'm not quite certain what that meant. Does that mean 100% of the students or
100% of the students.
100% of the courses?
100% of the students. So let me take you back some slides away. Okay, as you can see over here, in our year 1 and year 2, we actually have the core and foundational modules, which our students run through, right? So what happens is that we will infuse cloud computing generally in this sector here, because these modules are something that all students will actually run through, right? Versus an elective over here. So we will infuse all the cloud elements inside the core module so that every student has an opportunity to learn about what cloud computing is all about. And if they come over here in the year 3 and they still want to know more about cloud computing, there are modules such as the cloud computing security, cloud computing business applications and all that, which they can learn more in-depth knowledge on cloud. So it's 100% student infusion in terms of them understanding what cloud computing is all about.
What fraction of the courses have significant cloud computing components?
Okay, so in our 7 IT diplomas, we have actually infused cloud computing mostly in the year 2 curriculum, because that's when the students are actually brought up to a level where they are able to understand the different concepts that need to be taught.
Any more questions? I have a question. So, do you provide access through the university labs or student accesses from home? Do you see any changes in the pattern of using cloud computing?
At the moment, the Azure accounts are provided free from Microsoft. So the labs are actually conducted on campus, but as cloud, because it's an open space, right? So what happens is that the students are able to deploy it even from home. Yeah.
Do students and faculty like it? Or?
I think once we have actually done the fundamentals of what cloud computing is all about, they love it because they have the ability to do it, upload their solutions from home, from in fact anywhere that has an internet connection. And they are able to see and collaborate together as a team.
The question in the back here. Steve.
Course material, is that Microsoft provided or others?
Okay, we are actually using the Cloud for Classroom kit, and this was actually developed together with Microsoft with inputs together.
More questions? Thank you very much, Gary. Thank you. While our next speaker is setting up, and just briefly, if you're interested, there is a DVD with cloud computing resources available. These are curriculum resources provided by Microsoft and by some of the speakers, and this is a good opportunity to introduce our next speaker, Seung-won Hwang. She is from POSTECH. She's a professor there, and she will be talking about teaching web-scale data management using Microsoft Azure. Seung-won actually is one who contributed several curriculum resources and classes she implemented in both operating system but also in databases, and the latter is web-scale data management is her specialty. She is graduated from University of Illinois, and she has a lot of collaboration and very active in some ICM and IEEE committees. And talking about the contribution of curriculum and access, as I mentioned, Microsoft provide today, the latest is 5-month pass to be used by faculty and students, and it does not require a credit card, okay? And this is very important. We find some student and faculty reluctant to use credit card because sometimes students forget and get charged. So there is no credit card, and if you're interested, we have web-based applications, or you can approach me for a quicker solution. With this, I will introduce the next speaker.
Thank you, Arkady, for the introduction. Today, I'm very happy to talk about my experiences of using Microsoft Azure for teaching database classes. And my name is Seung-won, and I'm an associate professor at POSTECH Korea. So let me start my talk with establishing the background of my institute and also the course offering that I'm going to talk about today. So POSTECH is Pohang University of Science and Technology, and Pohang is actually the name of city we are located at, which is right here. We are another young school. We are about 25 years old. We are a little older than NYP, but still very young. And we are a top-tier research-oriented university. We have about 10 departments in undergrads covering science and engineering domains. So every year we get about 30 undergrads in computer science. So that's quite a small number. Our vision is having a very small private university of good faculty-student ratio. And in our department, we have about 20 computer science faculty. Okay, in terms of research interest, I say I'm a database person. And myself and many database researchers are actually working with web data. So we are not just working with nicely structured database table data stored in a single machine, but we are interested in supporting various forms of data collected and growing every day in an unprecedented scale on the web. So that will be my research background. And with this background, I teach, I taught operating system class 2, but mostly I teach database classes in both undergrad and the graduate level. So today, I'll talk about our undergraduate course offering, which took place in the fall semester last year. So this could be viewed as an infusion of Windows Azure technique for the database curriculum, but it is a little different in a sense that it's a little different from what's shared in the previous talk in a sense that it's not a separate module of introducing Windows Azure technique. It's more like we are offering a very classic database curriculum and try to infuse Windows as a mini segment, a project segment, such that students can view new challenges in terms of data research and the industry needs. So I'll share more about this in the later slide. So to talk more about this course offering, this happened in the last year, in the fall semester, there were about 40 students registered. And every week we have 3 hours of classroom teaching covering the classic database curriculum material. And we have 1.5 hours of lab where I can introduce many database techniques to the students. So I think many of you already took database courses, but let me remind you of what are the topics that are typically taught in the database curriculum. So we talk a lot about this nice table data. So if you are Amazon.com and you have information about millions of products you are selling, and we assume these kind of informations are stored in this nice table. So this will be example information of camera that are currently sold at Amazon.com. So in database class, we talk a lot about how the information we have can be nicely represented in the table forms like this, and also the background formal techniques of relational modeling and algebra for representing data in the table forms. And then we talked about this a lot in the plenary session. There is this nice language called SQL, declarative SQL language, where users can specify what they want so that they can narrow down a large data into the one they actually need. So in this query example, this person has only about $600 as a budget to buy a camera. So a lot of cameras are not relevant for this user, then it will be narrowed down to this camera. So then in database class, we talk a lot about how to write what you want in this kind of language. And then we also talk about query processing techniques, of all kinds of techniques for getting this kind of result very fast. So that will be the very classic scope of database curriculum. And since this SQL language and working with database management system with all those structured data are very relevant to the industry needs and research, we spend a lot of time teaching students how to work with this database management system and also how to work with SQL queries and so on. So that is the classic scope and possibly what you have learned in your database courses. And in terms of lab projects, there are usually two directions. One of the direction is building some web application using the database as the underlying storage. So we talked about these camera tables. Then we build like Amazon.com like web application where users can use this kind of UI to specify what they want. Instead of writing SQL query, we cannot expect Amazon customers will write what they want in terms of SQL query. Then this web application will translate this UI input into the relevant SQL queries, then present the result, not as a table, but this nice output for the users. So since a lot of commercial websites are working like this, this is very relevant to the industry needs. So this is one direction of course projects. And another direction is looking into what's actually happening inside the database engine. So just like operating system courses are doing some kind of project to read the kernel code and modify it. We heard about this in the first presentation of this session. Database management system is another big code corpus that is being discussed in the CS curriculum. So we again, in a lot of curriculum, we discuss what's going on inside of the database engine. And since this is a very complex code base, there is a simplified version of this code base provided from University of Wisconsin. And also, if you want open source database management, there is a nice code base originated from this very campus, UC Berkeley. So using a lot of database curriculums use these two kinds of tools to support projects where students can actually modify the modules inside the database engine or add something like rank query processing on top of the working database management system. So this was the background that's what has been usually being taught in the regular database curriculum. So today I want to talk about why we try to combine Azure, introduce Azure into this database curriculum. The first reason is that this curriculum, classic curriculum, has not changed much for the last 10 and 20 years. I took database class as an undergrad in Korea, and also I took like database as a grad student in USA, and I also taught database classes in USA and Korea, and all those curriculums follow pretty much the same format, which is the format that I just showed you. But within these 10 or 20 years, there has been a lot of changes in terms of the topics that has been discussed in both research and industry. So I think this is suggesting that there is a gap between what's being taught in the curriculum in terms of database versus what's been talked about in the research and industry fields. One example is this term big data. Actually, this will be the topic of the panel tomorrow, and this has been buzzword in both research and industry. And you can define this term in many ways, and my personal favorite definition is from Wikipedia. So Wikipedia says in information technology, big data means data sets that are large and also growing so large, so they become awkward to be processed using existing online database techniques. So we want to work with this big data, either collected from eScience, as we discussed in the plenary session this morning, or collected from the web, or collected from the sensor. this is just too big. So to be stored, searched, or shared, analyzed, or visualized using the existing technique. So my favorite word in this definition is awkward. I think this is actually emphasizing the gap I was talking about. So the technology we are talking about in the classic curriculum are often too awkward to support big data that are being collected in many sources these days. So why is it so awkward? And people talk about like 3 challenges of supporting big data, and these 3 challenges all start with letter V. So people talk about this as 3 V's of big data. It is very awkward to support storage, search, and so on, because volume-wise it is very big. So sometimes this data cannot be stored in a single machine. And also they are growing, and also these data need to be processed so fast, either real-time or near real-time. So this search or analyze computation needs to be very fast. And if you rely on one node, this kind of velocity cannot be achieved. And also another thing is this variety. So in classic database curriculum, we talk about nicely structured data on the table, but in actual data that is collected from the web is in a variety of forms, including search logs, unstructured text, videos, and audio. So the good data management techniques should support a variety of forms. So I'm thinking the goal of this curriculum design of introducing Azure to the database curriculum is to expose students to see these new challenges that have been discussed in research and industry. So students can realize that though we talk about like database management system hosted in a single machine in the textbook, students will be able to see that sometimes data are just too big. So maybe those data need to be stored distributedly over multiple nodes, or sometimes analyzing this data is too complex that those computation needs to be distributed. And also, a lot of time, our application should support not only nicely structured table-like data, but also very ugly forms of data, different forms of data. So the goal of designing a project for my course is exposing students to these 3 B challenges. But while doing that, I do not want to lose the original material because they are still very relevant for the students. So I want my course to be backward compatible in the sense that it is covering all the original materials and add new material. But when we are doing that, we want to minimize the additional learning curves, because if there is too much overhead for the new material, students will complain a lot. So this will be my design goals. And toward this goal, the specifics of what I did was that, again, this is not generating a new course talking about cloud computing or how to work with Windows Azure. Rather, we are covering the classic database material using, in my case, I'm using the textbook from University of Wisconsin. And also, we are still covering all the details about database management system and SQL query. We can use either regular database management system like SQL Server, or we can use SQL Azure for this purpose. And then we want to add this big data project so that the students can see sometimes they need to work with large data of various forms with distributed computation and storage. And specifically, we use Twitter graphs in combination with structured data. So let me show you details about this Twitter project. So I think a lot of you are using Twitter, and even for this conference, we have Twitter feed. So Twitter, as of this year, has about 140 million users. And in this graph, each user is a node. And each node has structured information about the user, like name or gender, location, profiles, and so on. And then there is this relationship between the node, but one particular thing about Twitter is that this relationship is asymmetric and it may not be mutual. So in Facebook, if A is a friend with B, that automatically means B is a friend of A. But in Twitter, A may follow B, but B may not be following A. So inspired by this asymmetry, I designed a very simple problem that students can work with. So we provide a large graph of many Twitter nodes. And then what student needs to do is they need to upload this to the Azure blob. And then they need to store the relationship between Twitter accounts in Azure tables. And then what they need to do is to count for each user how many of their follower relationships are mutual. So for some user, they have 10 followers, and this user is following back all those 10 users. In that case, mutual count or ratio will be 100% or 10. But there will be another user who is following a lot of people, but not followed by those people, and so on. So different accounts have different characteristics, and we can sort of use this mutual relationship count to explain those kind of different relationship. Well, if the graph is very small, then counting this mutuality of the relationship will not be very expensive. But in a large graph like Twitter graph, this kind of computation can be very complex. So the design goal of the students will be distribute this load of computation and storage, the computation to nicely, such that this kind of job can be done in a scalable manner. And since building some web application on top of database is also an important experience for the students, we will ask students to build this into a web application. But when we are doing that, we are providing a template code. So this is an example of web application, and each button represents each step that I just described. And when this is clicked, then the module will be called, and we actually provide what kind of codes that needs to be written for this module. So students will, providing this template is just to reduce the learning curve of the students so that students can start right away with their projects. So what they need to do is they need to store this large graph to the cloud storage and then ask multiple instances of Node to work on a different part of the graph to count the mutual relationship of each person, and then they can ask to count the mutual relationship count for every account, and then those count can be aggregated to figure out the users with high mutual relationship count or ratio. And then there is SQL Azure storing the structured information of different Twitter accounts, and based on this ID that we figured out, based on this ID, we can execute SQL queries to come up with to get the information, the user information about the ID that we just found. So this will be how this will be the overview of this project. And so we provide this code, and once students fill out this template, so actually this is not a lot of code. It's about 250 lines in C# code. So in terms of amount, it is not big, but students still spend a lot of time figuring out how to work with Windows, Azure, and so on. So still it costs the student a lot of time. And then once their codes are up and running, they can check it using Azure emulator. Here, so this screenshot is showing that 3 instances are parallelly working on counting the mutual relationship. And once they are done, they can use what has been developed in the emulator and deploy it in the actual web app at the Azure. And again, students have a lot of needs to invest a lot of time to figure out how to do it. So to reduce this learning curve, we provide like video material so that students can follow step by step without spending too much time figuring out how to work with these tools. So that was the brief overview of the project problem that we worked on. And in terms of outcome, quantitatively, students evaluated the quality of this project material quantitatively in the average of 4.64 out of 5.0. So I see this as a positive sign. And from their qualitative evaluation, the majority of students found that adding this kind of material helped them to see this new challenge and actually helped them to understand the challenges in database management, new challenges in managing big data, and also the majority of students found that this kind of experiences will be helpful for their future careers. And in case of you are interested in doing a similar kind of project for your course, I uploaded all the materials like the template we use and also the PowerPoint describing these projects and also the videos all nicely zipped and uploaded in this website. And I believe it is also available from the kit that you have. So so if you are interested in doing a similar kind of project, you can use that as a reference and also can give us feedbacks about how we can do it differently for the future offerings. So with that, I want to conclude this talk. So in summary, for me, I find adding Azure was useful to help students to see these new challenges of supporting big data and how to extend what the techniques they learned in the textbook for supporting those new type of data. And always students' learning curve is steeper than what instructors think when they are exposed to the new tools and the new source code. So those students need to be hand-holded in the beginning, and for that, always the template or video resources I find those kind of resources are quite helpful for students to start with the initial part of their projects. And thankfully, students found these projects quite relevant and helpful for their projects, for learning database curriculum. And then, since this big data is not just relevant to database field, this big data challenge can change the way we think about algorithms or data structures and various parts of classic curriculums of CS. So it is good to have like separate course on cloud computing, but I'm thinking many of you are coming from different domains and maybe teaching different kind of courses, but I think it will be an interesting thing to have some kind of mini segment to help students see like the classic material in a different angle of having a big data or having multiple nodes at hand. So I think my talk is one example of doing that in the classic database curriculum. And I'm sure if students find this helpful, then maybe this kind of mini segment can be developed for other computer science curriculums as well. So that will be the end of my talk, and I would be happy to answer your questions. Thank you.
Thank you. Any questions? Here's a question here.
Our first question is, how many database courses do you have in your curriculum?
Right. Well, we are a small university, so we only have one each for both for undergrad and undergraduate.
Okay, so this is what I have the impression that you introduce elements of distributed databases in the undergraduate project.
Yeah. So yes, the offering that we talked about is for undergraduate students, and students taking this course is mostly sophomore, junior level undergrad.
And so they do not have knowledge on the internal aspects of the database, like indexing or transaction management?
In the beginning, yes, but like the second half is talking about the internals, how the internals work. So they do learn about that at the 2/3 point of the curriculum, and the project is introduced around that time, so they have some initial working knowledge of the internals of database.
Of the database. So thank you.
Yeah, thank you.
So it looks like the premises that you're going to have in the future, these platforms as the main vehicle for students to be learning on. For example, Azure.
Yes.
But they do actually cost money. So I'm wondering how is the funding model going to work out?
For supporting student accounts for teaching, for this one, we collaborated with Microsoft, so we didn't have funding issue. But to make it sustainable, I think we need to come up with a good model to come up with the cost. Maybe Microsoft can keep supporting us, or we can figure out more sustainable way to manage this collaboration.
Any more questions? Did you find students motivated by using this Twitter project?
Yes, since, social network data, since students actually do use them, both Facebook and Twitter, quite actively, so they find it more fun and relevant to work with the social network data than usually the previous project mostly worked on enterprise, like product data, which is something that for students, it is harder to relate on those data than like relationship between friends and figuring out which account has like different types of accounts. They find it more interesting. Yeah.
Do you recommend any other public or accessible big database that could be hooked up for projects?
I think as soon as you expand your focus of data, not just to the structured data, but to unstructured data, the public data set you can work with is increasing exponentially because of those public big data. There are so many public big data sets, both in, not just in the domain of social network service, but other domains, so that can be easily acquired, and so there is this linked open data. There are lots of, in these linked graph forms of data, there are lots of big data sets that can motivate students and also similarly present these 3B challenges. So I think a different data set, or more interestingly, the combinations of data sets will be another good project target for the similar courses.
Thank you very much.
Thank you.
And thank you for all three speakers for being on time.